Okay, good morning everyone. For the last couple of days we have spent time multiplying polynomials, adding polynomials, and subtracting polynomials. Today we'll look at dividing polynomials. And the method that we'll use to divide polynomials for the most part in this chapter, which you will be expected to know on your test, the method that we will use will be synthetic division. So I'll go through what synthetic division is, but I'll also go over long division. So long division, remember that stuff way back in 5th and 6th grade, long division. But we'll be doing long division of polynomials. So let's recall what long division is. So think back to 5th and 6th grade, and we were dividing 277 by 12. 277 was called the dividend, and then 12 was the divisor. So we asked ourselves, well, how many groups of 12 go into 27? And there's 2 groups of 12 that go into 27. So to recall, we'd put the 2 there. And then we would multiply 2 times 12 will give us 24. And then we would subtract. 27 minus 24 gives us 3. And then we would bring down the 7. And then we would say how many groups of 12 go into 37? Well, there's 3 groups of 12 that go into 37. We'd multiply 3 times 12 will give us 36. And then we would subtract and we get a remainder of 1. So 12 was not a factor of 277. And when we got that remainder of 1, if you recall, we would write our answer as 23, which was our quotient, and 1 over our divisor. So 23 and 1/12. Arithmetic long division, I'll just do one more. So let's say here I was dividing 104. That was my dividend. My divisor was 4. And so I'm dividing 104 by 4. So I would say there's 2 groups of 4 in 10. So 2 times 4 is 8, and then I'd subtract. I'd get 2, and then I'd bring down the 4. And then I'd have 24, and then I would say there's 6 groups of 4 in 24, and I'd subtract. And I get 0. So we would say that 4 is a factor of 104. Well, 4 times 26 is 104. Or 26 is a factor of 104. Okay, so when the divisor is a factor of the dividend, we'll always get a remainder of 0. When the divisor is a factor of the dividend, we'll always get a remainder of 0. Now, division of polynomials, the process is the same, except now we're dividing polynomials. Okay, so here, in the way we do this, I'm taking the dividend as 2x squared plus 7x plus 7, and I'm going to divide that by x plus 2. So we only look at the leading coefficients here, or the leading terms, I should say, 2x squared and x, when we do long division of polynomials. So I would take 2x squared and divide it by x, and that would give me 2x. So that would give me 2x. They put the 2x over the 2x squared. It should really be over the 7x. Okay, so 2x squared divided by x is 2x. And then we would take 2x, and we will multiply that by x plus 2. And that would give me 2x squared plus 4x. And we'd put that there. And then we would subtract. Okay, and then 7x minus 4x gives me 3x, and we bring down our 7. Okay, so again, we're looking at just the leading term, so I would take 3x and divide it by x. So 3x divided by x, that would give me 3, and then so we would write plus 3 up there. And then we would take 3 times x plus 2, and that would give me 3x plus 6, and then we would subtract. And 7 minus 6 is 1. There's nothing else to bring down, so we have a remainder of 1. Okay? So that's, and I'll do a couple more. So we would say that x plus 2 then is not a factor of 2x squared plus 7. It's not, because we got a remainder of 1. X plus 2 was not a factor of 2x squared plus 7. All right. The other, so if I looked at this, you know, my divisor was x plus 2. Was x plus 2. If x plus 2 had been a factor of 2x squared plus 7, we would have gotten a remainder of 0. Or in other words, okay, my 0 for x plus 2 would be equal to negative 2. So we would have said then that the 0, negative 2, okay, was a 0 of 2x squared plus 7x plus 7. When I graph that, though, you see, so that's 2x squared plus 7x plus 7. But you see, I don't have my 0, negative 2, I don't have a 0 of negative 2. I'll explain that a little more. But x plus 2 then would not be a factor of 2x squared plus 7x plus 7. So let's look at this here. So let's say here I was multiplying x plus 2 times x plus 3. Okay, and then I get x squared plus 5x plus 6. Well, I know for certain then that x plus 2 and x plus 3 are factors of x squared plus 5x plus 6. Okay, because I multiplied the two together. I multiplied those two factors together, and I got x squared plus 5x plus 6. Okay, so if I take x squared plus 5x plus 6 and I divide it by x plus 2, I should get a remainder of 0. Okay, I should get a remainder of 0. All right. But now notice here, if I find the zeros of that polynomial x squared plus 5x plus 6, the factors are x plus 2 and x plus 3. If I find the zeros, I get negative 2 and negative 3. Okay, well, we know that x plus 2 is a factor of x squared plus 5x plus 6. Okay? Now, if I graph x squared plus 5x plus 6, I'll see that I do have zeros of negative 3 and negative 2. I'll have zeros of negative 3 and negative 2. Okay, so one way we can determine whether or not a x plus 2 or x plus 3 is a factor of x squared plus 5x plus 6, we could do long division of polynomials, and if we get a remainder, then x plus 2 or x plus 3 is a factor. Or we could just take the zeros. We could take the zeros of x plus 2 and x plus 3, which is negative 2 and negative 3. And if we plug them into the polynomial, if I substitute those zeros into the polynomial, and if I get 0, then that means that x plus 2 is a is a factor of the polynomial. If I substitute negative 3 into the polynomial, x squared plus 5x plus 6, if I get a remainder of 0, that means negative 3 was a 0 of that polynomial, or x plus 3 was a factor. Negative 2, when I substitute negative 2, I got 0. Okay, so that was a 0 of that polynomial, or x plus 2 was a factor. So let's look at some more here then as we go along. And let me disable my keyboard because it's driving me crazy here. All right. Now, so I did this long division up here. So I'm just going to change 7 to 6, so that means I won't have a remainder of 0. I'll have the remainder of 0. So again, I do long division. So now I'm going to take 2x squared plus 7x plus 6 and divide it by x plus 2. So again, we just work with the leading terms. Okay, so 2x squared. 2x squared divided by x gives me 2x, and I put my 2x there. And then I take 2x and I multiply that by x plus 2, and it gives me 2x squared plus 4x. Then I subtract. Okay, 7x minus 4x gives me 3x, and I bring down the 6. So now again, I take now again the leading terms. I take 3x and divide it by x, and I get 3, and I put that there. And then 3 times x plus 2, well, that gives me 3x plus 6. And then I subtract. and then I get 0. So we know with certainty then that x plus 2 is a factor of 2x squared plus 7x plus 6. I got a remainder of 0. Not only is x plus 2 a factor of 2x squared plus 7x plus 6, but also 2x plus 3 is a factor. Okay, if I take 2x plus 3 and multiply it by x plus 2, I'll get 2x squared plus 7x plus 6. If I looked at the graph of 2x squared plus 7x plus 6, I'll see I'll have zeros of negative 2. Okay, and that makes sense because if I take my divisor x plus 2 and set it equal to 0, I'll get negative 2. So so that would be my 0 of that factor x plus 2. And if I substitute that 0 into the polynomial 2x squared plus 7x plus 6, I'll get 0. Okay, I'll get 0 because negative 2 is a 0 of the polynomial. That's what it means to be a 0 of the polynomial. It's an x-intercept. The x-intercept is when y is equal to 0. 2x squared plus 7x plus 6 is y, and y will equal 0 at the 0 of negative 2. And then likewise, if 2x plus 3 is a factor, and it is, so 2x plus 3, if I find the zeros there, I'll get x is equal to negative 3 halves. Well, this is negative 3 halves, negative 1.5. If I substitute negative 3 halves, into the polynomial, if I substitute the 0 into the polynomial, 2x squared plus 7x plus 6, I'll get 0. Right? So there. And then one more here. So let's say here if I have x squared plus 5x minus 28, and I divide that by x minus 3. Is x minus 3 a factor of x squared plus 5x minus 28? If I do long division and I get a remainder of 0, then x minus 3 is a factor. Okay, so again, here we go. We take the leading terms, x squared divided by x squared divided by x, and that gives me x. I'll put that there. And then we take x times x minus 3. That gives me x squared minus 3x. Then we subtract. So 5x minus negative 3x is 8x, and we bring down the negative 28. Then again, I take the leading terms, 8x divided by x. That gives me 8. So I'll put that there, positive 8. And then again, we take 8 times x minus 3, and that gives me 8x minus 24. And then we subtract. And so a negative 28 minus a negative 24 gives me negative 4. So x minus 3 was not a factor of x squared plus 5x minus 28. We didn't get a remainder. Well, that's long division of polynomials, which we don't do too much. You'll do much more of that in pre-calc and calculus. Okay, but I avoid it on the test, okay, because most of what we do is synthetic division. So let's look at the process of synthetic division. Synthetic division works like this. So we have a polynomial 2x squared plus 7x plus 9, and we're going to divide that by x plus 2. So how do we do synthetic division? Well, I'm dividing by x plus 2. Oh, another thing I want you to notice here, okay, because this is going to be very important. When I did, so with this problem here, I started with x squared plus 5x minus 28, and then I divided it by x. Okay, my quotient, which is what's above the line there, will always be 1 degree less. So I started with x squared. If I divide by x, I get x. So the quotient is always 1 degree less. And I'll show you what I mean. Okay, so here I took 2x squared and divided by x. I got my quotient starts with 2x. My quotient is always 1 degree less than what I started with. Very important point. 1 degree less. Okay, so synthetic division here then, I have 2x squared plus 7x plus 9, and I'm going to divide that by x plus 2. Synthetic division works like this. Okay, So I'm dividing by x plus 2. So what I want to do is get the potential 0 of x plus 2. And I say potential because it really may not be a 0 of the polynomial. If it's a 0, I should get a remainder of 0. So I'll say x plus 2 is equal to 0, x is equal to negative 2. But remember, negative 2 may not be an actual 0 of the polynomial. Or in other words, it may not give me a remainder of 0 when I do division. So what we do is we take that potential 0 and we put it there. And then we put a box around it. And then we take the coefficients 2x squared plus 7x plus 9 from 2x squared plus 7x plus 9, and we put them there. So there's the 2, 7, and a 9. Okay, so we take the potential 0 of the divisor, that's negative 2, and then we write the coefficients for the dividend, 2, 7, and 9. And I'll mention now, but you'll see later, that if I have any missing terms in the dividend, 2x squared plus 7x plus 9, I have to use a 0 for missing terms, and I'll show you that. So the process then of synthetic division, the first thing you do is you bring down that first coefficient, 2. And then you take negative 2, and you multiply it by 2, and that gives you negative 4. And you put it under the next coefficient. Then you add 7 plus negative 4, and that gives you 3. You repeat the process. You take negative 2 times 3, and that gives you negative 6. You put it under the next coefficient. And then you add. 9 plus negative 6 gives me 3. Okay, and I'm all done because I've exhausted all the terms. Here I had 2x, so I had 2x squared plus 7x, and then plus 9 times x raised to 0. When I say I exhausted all the terms, I mean I accounted for every variable of x, 2, 1, and 0. And you have to account for every variable of x. Okay, so after exhausting all the terms, this becomes my remainder, which we put a box around it. Okay, so my remainder is 3, which means x plus 2 was not a divisor of 2x squared plus 7x plus 9. Now, how do we interpret this here, this 2 and the 3? Well, notice here, I started with 2x squared plus 7x plus 9, and I divide by x plus 2. So I have reduced the degree by 1. So, for example, if I had x to the third and I divided it by x, I'd get x squared. I reduced the degree by 1. If I had x squared divided by x, I'd get x. I reduced the degree by 1. So when we do synthetic division, we'll always reduce the degree by 1. Our final answer will be 1 degree less. So we would interpret this 2 then as 2x. And then so this would be 2x plus 3. And then we would write our remainder 3 over our divisor x plus 2. Okay, so let's just do a couple more of these. Synthetic division. All right, so here again, I'm taking 6x squared minus 5x minus 6. And I have all the terms of x. I could write this x raised to 0. I have the 2 and the 1 and the 0. And I'm going to divide by x plus 3. So let's see here, my potential 0 then, x plus 3 equals 0, x equals negative 3. That's my potential 0. Again, it may not be a 0 of that polynomial because x plus 3 may not be a factor of that polynomial. So I just call it a potential 0. So we take that negative 3 and we put it here. And then we write the coefficients for the polynomial 6, negative 5, and negative 6. So 6, negative 5, and negative 6. And then we do synthetic division. We bring down the 6, and then we multiply. Negative 3 times 6 gives us negative 18. We put it under the next coefficient. Then we add negative 5 plus negative 18 gives me negative 23. Then we multiply negative 3 times negative 23, and we get 69. And then we add and we get 63. Okay, and so 63 is the remainder, which means then that x plus 3 was not a factor of 6x squared minus 5x minus 6. And again, I started with x squared, 6x squared, and I divided by x. So my quotient will be 1 degree less, so I'll interpret 6 as 6x. and then minus 23 with the remainder of 63 over my divisor x plus 3. Let's look at some more here. So here I'm take 3x to the fourth minus x cubed plus 5x minus 1, and I'm going to divide by x plus 2. Again, my potential 0, okay, I have to find my potential 0, so my potential 0 will be negative 2. Now I want you to notice here I have the 4, the 3, but I don't have the 2, x squared, so I'm going to have to write that in. So basically I will have this. I'll have 3x to the fourth minus x cubed, but because I don't have the 0, I better account for that, otherwise synthetic division is not going to be right. I'll have 0x squared. And then I have my 5x and my minus 1, which I can write as x to the 0. So I have all the exponents, 4, 3, 2, 1, and 0. You must account for all of the missing terms. Otherwise, you'll get synthetic division wrong. You must account for all the missing terms. If you're missing a term, add 0. 4, 3, 2, 1, 0. All right, so my potential 0 was negative 2, so I put that in the box there. And then my coefficients are 3, negative 1, 0, 5, and negative 1. Okay, so I set that up. Now we do synthetic division. Bring down the 3. Take negative 2 times 3, you get negative 6. Add negative 1 and negative 6 gives you negative 7. Take negative 2 times negative 7, you get 14. Put it underneath the next coefficient. 0 plus 14 gives you 14. You multiply again. Negative 2 times 14 gives you negative 28. You add 5 plus negative 28 gives you negative 23. You multiply again. Negative 2 times negative 23 gives you 46. And then negative 1 plus 46 gives you 45. Let's see here. At what degree did I start with? I started with x to the fourth. 3x to the fourth. I'm dividing by an x, so my degree and my dividend, my answer, has to be 1 degree less. So we would interpret 3 as 3x cubed. And then this would be minus 7x squared. And this 14x minus 23. And the remainder of 45 over our divisor, x plus 2. Okay, so that's synthetic division. Synthetic substitution is like synthetic division without all the steps. Just substitute the potential 0 into the polynomial to find the remainder. Okay, to find the remainder. Okay, and I kind of started that up here. If I go back up here, so what did I do that? Okay. So for example, when I took 2x squared plus 7x plus 6 and I divided by x plus 2, I got a remainder of 0. Well, I could take the 0 for x plus 2, which is negative 2. Yeah. The 0 for x plus 2, which is negative 2. And if I substitute that into 2x squared plus 7x plus 6, this is like synthetic substitution. I should get the same remainder as I got when I did log division, and I get 0. Okay, I get 0. And then the other factor was 2x plus 3. So if I said 2x plus 3 equals 0, okay, I get a 0 of negative 3 over 2. If I substitute that into my polynomial, 2x squared plus 7x plus 6, I'll get 0 again. Okay, so when you do synthetic substitution, you should get the same remainder as you would if you did long division or synthetic division. Okay, so synthetic substitution is like synthetic division, it's just without all the steps. Okay, so let's look at this here. So synthetic substitution is like synthetic division without all the steps. Just substitute the potential 0 into the polynomial to find the remainder. So I'll show you what I mean. Okay, so here I had 3x to the fourth minus x cubed plus 5x minus 1, and I'm dividing by x plus 2. My potential 0 is negative 2. Now, so So let's say here that's my function f of x is equal to that. And if I substitute a -2 into the polynomial, so that's 3 times -2 to the 4th, minus -2 to the 3rd, -2 to the 3rd, because again it's -2, so that better. And then plus 5 times -2 minus 1. I should get the same remainder that I got when I did synthetic substitution. My remainder here was 46. So again, if I take that potential 0 and substitute it into the original polynomial, that's called synthetic substitution, I should get the same remainder that I got when I did synthetic division. And so what's -2 to the 4th? That's 16. So 3 times 16, -2 to the 3rd, a negative raised to an odd is going to be negative, so that would be -8, but a -8 will give me a +8. And then 5 times -2 will give me -10, minus 1. So 3 times 16, what is that? 48, right? So I have 48 plus 8 minus 10 minus 1. So I have 56 minus 11. And that gives me 45. Yeah, 56 minus 11 gives me 45. Same remainder. Same remainder there. Okay, so that's synthetic substitution. So let's take a look at the last example here. So here we're going to do synthetic division first, and then we'll do synthetic substitution. So notice here I'm taking 2x to the 4th plus 8x cubed plus 2x plus 8, and I'm dividing by x plus 4. So my potential 0 is going to be -4. So I'll put that there, put a box around it. But I'm missing what the x squared, right? So this is actually 2x to the 4th plus 8x cubed plus 0x squared plus 2x plus 8. Okay, always account for every term of x. I have 4, 3, 2, 1, and the next raised to 0. Always account for every missing term. You have to. Right, so my coefficients then are 2, 8, 0, 2, and 8. Again, synthetic division. Bring down the 2. -4 times 2 is -8. Add 8 plus -8 is 0. So you get 0. Multiply -4 times 0 gives you 0. Add 0 plus 0 is 0. Multiply again, -4 times 0 is 0. Add 2 plus 0 is 2. Multiply again, -4 times 2 gives you -8. And then add, and you get 0. So we know with certainty that x plus 4 is a 0 of 2x to the 4th plus 8x cubed plus 2x plus 8. It is a 0. I mean a factor. X plus 4 is a factor. Or my 0 of that polynomial would be -4. If I graphed it, you would see a 0 of -4, an x-intercept. Okay. And so the way we interpret this, again, we started with 2x to the 4th, and I'm dividing by x, so my final answer is going to be 1 degree less. So this 2 would be 2x cubed. I don't have any x squared. I don't have any x. And then I just have 2. So my final, the dividend is 2x cubed plus 2 with no remainder. Now, if I do synthetic substitution, if I take -4 and substitute it into that polynomial, I better get 0 because I got a remainder of 0 when I did synthetic division. So if I substitute in -4, okay, I better get 0. Okay, so -4 to the 4, what's that? 256, and 2 times 256. 2 times 256, that's 512. And then negative 4 to the third is 64, right? Negative 64. And 64 times 8, well, that will be 32. And 48, and that would be 512, so that would be negative 512. And then 2 times negative 4 is negative 8, plus 8 gives me 0. It works. Okay, so that is called synthetic substitution. It's just a shorter method of determining whether or not the divisor is a factor of the dividend. If you get 0, okay, basically it's a remainder of 0. If you did synthetic division, you would get a remainder of 0. So x plus 4 is a factor of 2x to the 4th plus 8x cubed plus 2x plus 8. That's called synthetic substitution. It's just like synthetic division without all the steps.